Assalamu alaikum. Welcome to lecture number 10 of the course on statistics and probability. You will recall that in the last lecture I was discussing with you the concept of central tendency. In particular, we discussed the geometric mean and the harmonic mean, and after that we discussed a relationship that exists between the arithmetic mean, the geometric mean, and the harmonic mean. Also, towards the end of the last lecture, I conveyed to you two other measures of central tendency, the mid-range and the mid-quartile range. Today, I am going to begin with you another extremely important concept, and that is the concept of dispersion. Dispersion से क्या मुराद है? Dispersion का मतलब है the variability that exists in your data set. जैसा कि आप जानते हैं, किसी भी फिनोमिनन के बारे में जब आप कोई डेटा कलेक्ट करते हैं तो वो तमाम वैल्यूज एक बराबर नहीं होती, बल्कि सब एक दूसरे से वेरी कर रही होती हैं. यही जो वेरिएबिलिटी है, द वेरिएबिलिटी दैट एग्जिस्ट्स बिटवीन ऑल दीज वैल्यूज, this is a very important concept, and it is very important for us that we should be able to have some way of measuring the amount of variability that is present in our data set. Let me explain this point to you with the help of an example. In a technical college, it may well be the case that the ages of a group of first-year students are quite consistent. For example, 17, 18, 18, 19, 18, and so on. They may all be more or less of the same age. On the contrary, a class of evening students undertaking a course of study in their spare time may show just the opposite situation as far as the ages of these students are concerned. For example, their ages may be 35, 23, 19, 48, 32, and so on. I'm sure कि इस एग्जाम्पल से आपको एकदम से ये बात वाज़ेह हो गई होगी कि जबकि पहली क्लास में बहुत कम वेरिएबिलिटी पाई जाती है with regard to age, in the second class there is a lot of variability. यही जो concept है, this is the topic of our today's lecture, and it is a concept which is as important as the concept of average. लेकिन अजीब इत्तेफाक है कि एक लेमैन जो है वो एवरेज की बात तो काफ़ी आसानी के साथ समझ जाता है और उसके जहन में इंट्यूटिवली एक आइडिया होता है कि इफ देयर इज अ सेट ऑफ डेटा उसकी एक एवरेज वैल्यू होगी. लेकिन ये जो उसके साथ का ये दूसरा जो कॉन्सेप्ट है कि उसी डेटा में जो वेरिएबिलिटी पाई जाती है, एक लेमैन आमतौर पे समहाउ इस चीज को इतना ज्यादा अहमियत नहीं दे पाता या इतनी ज्यादा इसकी सिग्निफिकेंस को अप्रिशिएट नहीं कर पाता जितना कि एवरेज को करता है. मैं आपको ये कन्वे करना चाहती हूं कि दिस कॉन्सेप्ट इज एज इम्पोर्टेंट एज द कॉन्सेप्ट ऑफ एवरेज. आफ्टर ऑल, unless there is some variability in your data set, what is it that you are trying to average? Average तो आप करेंगे ही तब if there is variability in your data. Let me try to explain this to you with the help of another example. Suppose that the sizes of the classes in two comprehensive schools in two different areas are as follows. अब जैसा कि आप इस टेबल में देख रहे हैं, the first column represents the number of pupils in a class, in other words, the class size, and these class sizes are 10 to 14, 15 to 19, 20 to 24, 25 to 29, and so on. And it goes up to quite a large class size, and that is 45 to 49. लेकिन अब अगर आप उन दोनों एरियाज, उन दोनों लोकेलिटीज को कंपेयर करें, तो आप देख रहे हैं कि एरिया ए में there is not a single school in which the class size is 10 to 14 or 40 to 44 or 45 to 49. All the class sizes in this school range between 15 to 19 and 35 to 39. On the contrary, in area B, the situation is quite different, and we have 5 classes in the school whose class size is only 10 to 14, and on the other end of the table, we have 3 classes with class size 45 to 49 and 3 classes with class size 40 to 44. If we compute the arithmetic mean for both these areas, we find that the average class size for both the areas is identical, and it is 27.33. लेकिन स्टूडेंट्स, जैसा कि मैंने अभी आपको एक्सप्लेन किया, वेरिएबिलिटी के पॉइंट ऑफ व्यू से the two areas are quite different. And if we plot these two frequency distributions on the same graph, you will realize that the two distributions are absolutely different. As you now see on the screen, the spread of the distribution for area A is much less than the spread of the distribution for area B. But as I just mentioned, the average value, that is the arithmetic mean for both the distributions, is identical, and that is 27.33. अब ये तो वाज़े हो गया कि ये distributions identical नहीं हैं, in spite of the fact that the arithmetic mean is the same. तो अब crucial question यही है कि how do we distinguish between the two distributions? देखिए, graphically तो नज़र आ रहा है कि they are different, but it's not enough for me to just say that it's obvious from the graph that they are different. We have to have some numerical measure to measure the variability, the spread, the scatter of the distribution of locality A as well as of locality B. And the moment we have some proper numerical way of measuring these quantities, then of course we are able to compare the two distributions in a proper way. जैसा कि आपने central tendency के केस में देखा था, there were quite a few ways of measuring the central tendency of a data set. You remember all those things that we have discussed: the arithmetic mean, the geometric mean, the harmonic mean, the median, and the mode. इसी तरह, students, we have different ways of measuring the spread of our distribution. I will discuss with you 4 very basic and important measures of dispersion. These are the range, the quartile deviation, the mean deviation, and the most important and the most widely used, that is the standard deviation. लेकिन पेशतर इसके कि हम इनको एक एक करके पिकअप करें, स्टूडेंट्स, मैं आपको एक और नहायत इम्पॉर्टेंट पॉइंट कन्वे करना चाहती हूँ, और वो ये है कि ये जो चारों नाम मैंने अभी आपको लिए, दीज आर ऑल कॉल्ड एब्सोल्यूट मेजर्स ऑफ डिस्पर्जन। एब्सोल्यूट से मुराद ये है कि फॉर ऑल दीज मेजर्स योर आंसर इज एक्सप्रेस्ड इन द सेम यूनिट्स as your data set. Let me say this again. An absolute measure of dispersion is one that measures the dispersion in terms of the same units or in the square of the units as the units of the data. For example, if the units of the data are rupees, meters, kilograms, etc., the units of the measures of dispersion will also be rupees, meters, kilograms, etc. इसके बरक्स, a relative measure of dispersion is that which expresses the absolute measure of dispersion relative to the relevant average and multiplied by 100 many times, and in this way it is a pure number independent of the units in which the data has been expressed. Formally speaking, a relative measure of dispersion is one that is expressed in the form of a ratio, coefficient, or percentage, and as such it is independent of the units of measurement. Relative measure of dispersion compute करने का फायदा ये होता है कि because it is a pure number, therefore it can be used for purposes of comparison. You are able to compare the dispersion of one data set with the dispersion of another. Okay. Let us now begin the discussion of the various measures of dispersion one by one. I start with the simplest, and that is the range. The range is defined as the difference between the two extreme values of a data set, that is, R is equal to xm minus x naught, where xm represents the maximum value and x naught the smallest. आपको याद होगा कि ये तो वो क्वांटिटी है जिसको आप पहले भी टेक अप कर चुके हैं. You will remember that when you first learned how to construct a frequency distribution from raw data, this was one of the very first steps that you did. You found the range and then you divided it by the number of classes that you wanted to have. इस वक्त मैं इस क्वांटिटी का जिक्र dispersion, scatter, spread of the data set के हवाले से कर रही हूँ, और आप अग्री करेंगे कि इससे ज़्यादा सिंपल कोई मेजर हो ही नहीं सकता to determine the spread of your data. अगर आप इसको ग्राफिकली देखें तो जैसा कि अब आप स्क्रीन पर देख रहे हैं, it is the distance between the smallest value which lies at the left end of your distribution and the highest value which lies on the right side. I hope that from this diagram it is obvious to you that for any distribution which has a greater variability between the extreme values, this distance will obviously it will be longer. And for a distribution where it is a tighter distribution and there is not that much difference between the two extreme values, obviously the range will be a smaller quantity. As is obvious, the range is the easiest measure of dispersion. However, students, you must realize that it has two serious disadvantages. The first point is that it is based on only the two extreme values, and as such it ignores all the information that is present in the intermediate values. तो इसमें कबाहत ये निकलती है कि if we are trying to measure the variability of the data set, on principle, all the values should be utilized to compute this variability. Why is it that we are ignoring all this information that is in all these values which are inside? And the second point is that because of this very fact that it is only the two extreme values, students, sometimes the range can be quite misleading. For example, suppose that there is this test, this professor has conducted a test which was very difficult, and most of the students got very low marks, and the marks were something like 2, 3, 7, 4, 5 out of 20. लेकिन सिर्फ एक स्टूडेंट है who is very intelligent and he is able to get 18 out of 20 in this very test. अब अगर आप variability of marks measure करना चाहें by way of the range, what will you obtain? The highest mark is 18, the lowest mark is 2, and the range comes out to be 16. But you should realize, students, that this number 16 is not a very good representative of the variability that is present in this data set in all those marks which were quite low except for this one lone mark which was so high. अगर सिर्फ ये एक नंबर इस डेटा सेट में मौजूद ना होता तो बाकी नंबरों की रेंज 16 की निस्बत बहुत कम होती. And in this way, if you have an extreme value in your data set, the range is absolutely inappropriate as a measure of dispersion. Of course, there are situations where the range is appropriately used as a measure of dispersion. For example, in case of statistical quality control charts, in the case of stock prices, and also in the case of daily temperature. हर रोज हम आप टेलीविजन पे देखते और सुनते हैं कि आज का मिनिमम टेम्परेचर इतना था और मैक्सिमम टेम्परेचर इतना था. अच्छा, अब मैं आपके साथ एक टेक्निकल बात करने लगी हूं. देखिए, जिस तरह से मैंने रेंज की बात की वो तो इंतहाई सिंपल है और जाहिर है कि जब भी आप अप्लाई करेंगे तो आप इसी तरह इंतहाई सिंपली उसको आप कंप्यूट कर लेंगे. लेकिन the concept that I wish to convey to you now is that generally speaking, for any measure of dispersion, we would like to think of it as the spread of the values around a central value. यानी पहले हम अपने जहन में एवरेज को लाएंगे और उसके बाद हम वो जो स्प्रेड है वो हम उस एवरेज के अराउंड मेजर करना चाहते हैं. यानी इस एवरेज के हवाले से क्या ज्यादा स्प्रेड है from this average, or is it only a little bit? So let me now present to you the concept of the range with regard to an average that is relevant to the range. आपको याद होगा कि लास्ट लेक्चर के एंड में हमने मिड रेंज का जिक्र किया था, which was defined as x0 plus xm over 2. Now, the range can be defined as twice of the arithmetic mean of the deviations of the smallest and largest values around the mid-range. That is, the range is equal to mid-range minus x naught plus xm minus mid-range over 2, and this whole quantity multiplied by 2. And solving this expression, it will come out to be xm minus x naught, exactly the same definition which I gave you earlier. So बात ये बनी कि एक मिड रेंज है और एक उसका डिस्टेंस है फ्रॉम x नॉट, जिसे हम डिविएशन कहते हैं, और एक उसका डिस्टेंस है फ्रॉम xm, जिसको भी हम डिविएशन कहेंगे. और इन दोनों डिविएशंस का अरिथमेटिक मीन अगर हम ले लें और उसे डबल कर दें तो दैट इज इक्वल टू आवर रेंज. तो ये सारे इस मखमसे में पढ़ने की क्या जरूरत थी? Only to convey to you that the range also follows that basic concept that generally we are trying to measure the dispersion of our data set around a central value. ये तो हुई range. And as I said earlier, this is an absolute measure of dispersion. जिन यूनिट्स में आपका ओरिजिनल डेटा है उन्हीं यूनिट्स में रेंज भी एक्सप्रेस होगी. नाउ व्हाट इज द कॉरेस्पॉन्डिंग relative measure of dispersion? As you now see on the screen, the relative measure of dispersion relevant to the range is called the coefficient of dispersion, and it is given by half range divided by the mid range. In other words, xm minus x naught over 2 divided by xm plus x naught over 2, which on simplification becomes simply xm minus x naught over xm plus x naught. As I said earlier, this relative measure of dispersion is a pure number, and therefore it can be used for comparing the dispersion of two different data sets. For example, if the coefficient of dispersion of one data set comes out to be 0.6 and the coefficient of dispersion of another is 0.4, then it should be obvious that the spread of the first one is greater than the spread of the second one. और ये इस बात को मद्देनजर रखते हुए कि दोनों हमने relative to the central point measure किए हुए हैं. The next concept of dispersion that I am going to discuss with you is the quartile deviation, and it is also known as the semi-interquartile range. As you now see on the screen, the quartile deviation is defined as half of the difference between the third and the first quartiles. That is, quartile deviation is equal to Q3 minus Q1 divided by 2. आइए अब इस मेजर की ग्राफिकल पिक्चर पे गौर करते हैं. आपको याद होगा Q1 is that quantity which has 25% of the data before it and 75% after it. Similarly, Q3 is that quantity which has 75% area or data before it and 25% after it. So, as you now see on the screen, the quartile deviation, or in other words, the semi-interquartile range, is the horizontal distance which is exactly half of the distance between the first quartile and the third quartile. तो आपने देखा कि क्वार्टाइल डिविएशन भी एक हॉरिजॉन्टल लेंथ ही के जरिए एक्सप्रेस होती है. अब why is it that in both the cases, the case of the range and in the case of the quartile deviation, we are having this distance in a horizontal direction? Well, students, I hope that the answer is obvious to you. ये जो frequency distribution आपने plot की है, y axis जो है वो तो frequencies को denote कर रहा है, यानी how frequently a certain x value occurred. लेकिन जो x values खुद हैं, जो हमारा variable of interest है, जो हमारी डेटा वैल्यूज हैं, वो तो बहरहाल एक्स एक्सिस पर ही रिप्रेजेंट हो रही है ना. लिहाजा अगर हम उनकी आपस में वेरिएशन को मेजर करना चाहते हैं तो साफ जाहिर है कि दैट वेरिएशन इज गोइंग टू बी अलोंग दी एक्स एक्सिस. यही वजह है कि इसके बाद जब मैं मीन डिविएशन और स्टैंडर्ड डिविएशन का जिक्र करूंगी तो इवन दोज क्वांटिटीज विल बी एक्सप्रेस्ड एज हॉरिजॉन्टल डिस्टेंसेस बिलो द एक्स एक्सिस. कुछ देर पहले जब मैं रेंज की बात कर रही थी तो मैंने वाज़े तौर पे आपको कन्वे किया कि अगर हमारे डेटा सेट में कोई एक्सट्रीमली लार्ज या एक्सट्रीमली स्मॉल वैल्यू हो compared with the rest of the values, then the range is not at all suitable as a measure of spread. अब ये जो क्वार्टाइल डिविएशन है स्टूडेंट्स, इसमें आप नोट करेंगे कि वो जो रेंज का प्रॉब्लम था दैट हैज बीन ओवरकम. अब जो डिस्टेंस है इट इज द डिस्टेंस बिटवीन Q1 एंड Q3 और उसके बाद उसको हम हाफ कर देते हैं. और Q1 जो है दैट इज नॉट ऑन द एक्सट्रीम लेफ्ट ऑफ द डिस्ट्रीब्यूशन. Q3 जो है दैट इज नॉट ऑन द एक्सट्रीम राइट. उसके आगे तो 25% ऑफ द डेटा लाई करता है. इससे पहले भी 25% ऑफ द डेटा लाई करता है. लिहाजा there is no problem now the kind that we had in case of the range. So in this regard, the quartile deviation is superior to the range as a measure of dispersion. आइए अब हम quartile deviation को भी उस तरह इंटरप्रेट करने की कोशिश करते हैं जिस तरह अब से थोड़ी देर पहले मैंने रेंज के लिए किया था. As you now see on the screen, the quartile deviation can also be viewed as the arithmetic mean of the deviations of the first and third quartiles around the median. That is, the quartile deviation is equal to m minus Q1 plus Q3 minus m over 2, where m represents the median, and solving this expression, it comes out to be equal to Q3 minus Q1 over 2, exactly the same formula that we have for the quartile deviation in its basic definition. तो फिर वही पहले की तरह की बात कि एक तो हुआ मीडियन, एक हुआ फर्स्ट क्वार्टाइल और एक हुआ थर्ड क्वार्टाइल. नाउ द डिविएशन, that is the distance between the median and the first quartile, and then on the other side the distance between the median and the third quartile. We just simply take the arithmetic mean of these two deviations, and this gives us a way of measuring the dispersion of our data set. इस डिस्कशन से आप पे वाज़ेह हो गया होगा कि क्वार्टाइल डिविएशन हम उस सिचुएशन में इस्तेमाल करेंगे as a measure of dispersion, जिस सिचुएशन में हम मीडियन को इस्तेमाल कर रहे होंगे as the most suitable measure of central tendency. Students, quartile deviation possesses quite an attractive property, and that is that the median plus minus the quartile deviation contains approximately 50% of the data. As you now see on the screen, the median, of course, lies in the middle. The median minus the quartile deviation will be a point to the left side, and the median plus quartile deviation is obviously to the right, and the property that I have just conveyed to you says that 50% or approximately 50% of the data will lie between these 2 points, median minus quartile deviation and median plus quartile deviation. Students, मैं आपको एक क्वेश्चन थ्रो करती हूँ. फर्ज कीजिए कि हमारी 2 डिस्ट्रीब्यूशंस हैं, दोनों सिमेट्रिक हैं और दोनों का मीडियन बिल्कुल बराबर है, लेकिन एक का क्वार्टाइल डिविएशन दूसरे के क्वार्टाइल डिविएशन से दुगना है. ऐसी सिचुएशन में if you draw the graph of both the distributions on the same graph paper, what will you have? Obviously, the one which has the double quartile deviation, that will be much wider than the one which has the smaller quartile deviation. Let us now apply this concept of quartile deviation to an example. Suppose that the shareholding structure of 2 companies is as given in the table that you see on the screen. For company X, the first quartile is 60 shares, the median is 185 shares, and the third quartile is 270 shares. On the other hand, for company Y, although the median is exactly the same as that for company X, but the first quartile and the third quartile are quite different. The first quartile is 165 shares and the third quartile 210 shares. The quartile deviation for company X, therefore, comes out to be 270 minus 60 over 2, and that is equal to 105 shares. On the other hand, for company Y, it is equal to only 22 shares. Students, from these computations, I hope that it is obvious to you that there is considerable concentration of the shareholders around the median number of shares in company Y. In company X, on the other hand, we do not find this kind of a concentration. There is an approximately same number of small, medium and large shareholders. मुझे ये सब कैसे पता चला? The answer is very simple. Just look at the quartile deviations for the 2 companies again. For company X, the quartile deviation is 105 shares, but for company Y, the quartile deviation is only 22 shares. The larger the quartile deviation, the greater is the scatter of the values within the series, and hence it is obvious that there is greater concentration around the median in company Y as compared with company X. From the above example, it is obvious that the larger the quartile deviation, the greater is the scatter of the values within the series. Now the question is, how do we compute the quartile deviation in the case of raw data? For this purpose, let us go back to the example of the US zoological parks that we considered in lecture number 7. As you will recall, the example was displayed in the following table are the annual attendance figures in millions of visitors of 32 US public zoological parks. The figures are 0.6, 0.9, 0.2 and so on, and all these figures are in millions. Now, we would like to compute the median, the first and third quartiles, and the semi-interquartile range for this data. Of course, you all know that the semi-interquartile range is the same thing as the quartile deviation. In order to determine the values of the median and the upper and lower quartiles, students, we must first arrange the attendance figures in ascending order. As you now see on the slide, the arranged figures are 0.3, 0.4, 0.5 and so on. Now, because we have an even number of values, that is 32, therefore, the median is given by the average of the two middle values, which are 1.0 and 1.1. Therefore, the median, which is also known as the second quartile, is equal to 1.0 plus 1.1 and this sum divided by 2, and therefore, we obtain 1.05. As far as the quartiles are concerned, students, I would like you to first note the following general rule. In order to compute Pj, the jth percentile from a set of n observations arranged in order from smallest to largest, we need to proceed as follows. Number 1, when Jn over 100 is an integer, the jth percentile is given by the average of the Jn by 100th and the Jn by 100 plus 1th observations. Now, before I go to the second part of this rule, students, let us apply this first part to this particular example, because as you will just see, this first part is applicable in this particular example. We wanted to find the first quartile, Q1, and Q1 is the same thing as P25. Therefore, according to the rule, we are talking about J equal to 25. And therefore, Jn over 100 is equal to 25n over 100. And because n is equal to 32, therefore, 25 into 32 divided by 100 comes out to be equal to 8, and 8 is an integer. Therefore, according to the rule that I just mentioned, we have to compute the average of the Jn by 100th, that is the 8th, and the Jn by 100 plus 1th, that is the 9th observation. And students, the 8th observation in our ordered data set was 0.6, whereas the 9th observation was 0.7, and therefore, the average of the two comes out to be 0.65. So, this is the first quartile, or in other words, the 25th percentile of this particular data set. Similarly, in order to compute Q3, we note that Q3 is the same thing as P75, and therefore, we are talking about J is equal to 75. And hence, Jn over 100 comes out to be 24, and that is also an integer. Therefore, once again, we apply the same rule, and we need to find the average of the jn by 100th, in other words, the 24th, and jn by 100 plus 1th, in other words, the 25th observation. So, students, in our ordered data set, the 24th value is 1.4 and the 25th value is 1.5, and therefore, finding the average of the two, our third quartile comes out to be 1.45. Now, the interquartile range is given by Q3 minus Q1, and therefore, subtracting 0.65 from 1.45, we obtain 0.8 million, or in other words, 800,000 as the interquartile range. Now, students, what is the interpretation of this result that we have just obtained? It means that the middle 50% of the attendance figures span a range of 0.8 million. This value is displayed along with the quartiles and the attendance data in the slide that you now have on the screen. इससे आपको ये आइडिया हो गया होगा कि इंटरक्वार्टाइल रेंज दरमियान वाली 50% वैल्यूज को कवर करती है. But students, you remember that we were interested in the quartile deviation, which is none other than the semi-interquartile range. Therefore, all we have to do now is to divide what we just obtained, 0.8, to divide this by 2, and doing so, we obtain the quartile deviation equal to 0.4 million. Now, before I end this discussion, students, I would like you to go back to the general rule that I started from regarding the computation of the jth percentile from a set of n observations arranged in order from smallest to largest. In this regard, the point to be noted is, and this is point number 2 versus point number 1 that I stated earlier, that if jn over 100 is not an integer, then the jth percentile is given by the value of the jn by 100 plus 1th observation. But students, please note that I have a special type of a bracket around jn over 100 in this particular expression, and this kind of an expression with this kind of a bracket stands for the largest integer in jn over 100. Now, students, let me explain this with the help of a simple example. And using the same example that we were just considering, suppose that we are interested in computing the 7th percentile for the data of the 32 zoological parks, then j will be equal to 7, and we will have jn over 100 is equal to 7 into 32 divided by 100, and this is equal to 2.24. Obviously, 2.24 is not an integer, and according to the rule that I just mentioned, the 7th percentile will be given by the 2 plus 1th, that is the third observation. And why is this the case? Because, students, the largest integer in the number 2.24 is 2. So, we consider this largest integer and we add 1 to this number, and that gives us 3, and we say that the 7th percentile is the value of the third observation. So, students, this is the way in which we compute the various percentiles, quartiles, and deciles for raw data. Students, the quartile deviation is an absolute measure of dispersion. जैसा कि मैं आपको पहले बता चुकी हूं, absolute measure is that which is expressed in exactly the same units as the units of our data set. What is the relative measure of dispersion relevant to the quartile deviation? Students, it is known as the coefficient of quartile deviation and is expressed as the quartile deviation divided by the mid-quartile range. As you will recall, in the last lecture, the mid-quartile range was defined as Q3 plus Q1 over 2, and if I divide the quartile deviation, that is Q3 minus Q1 over 2, by the mid-quartile range, that is Q3 plus Q1 over 2, solving this expression, we obtain Q3 minus Q1 over Q3 plus Q1. Once again, this is a pure number and it can be used to compare the dispersion of two or more sets of data. Students, quartile deviation is definitely an improvement on the range, as I explained a short while ago, लेकिन इसमें भी ये problem है कि it is not based on all the values. You simply pick up the first quartile and the third quartile and you find their difference and you take half of it. The next two measures of dispersion that I am going to discuss with you, the mean deviation and the standard deviation, ये दो ऐसे measures हैं which are based on each and every observation in our data set. आपको याद होगा कि जब हम रेंज की बात कर रहे थे तो मैंने आपसे कहा कि वो जो मिड रेंज है गोया हम उसके अराउंड मेजर कर रहे हैं डिस्पर्जन. इसी तरह जब हमने क्वार्टाइल डिविएशन की बात की तब मैंने मीडियन का जिक्र किया था एज द सेंट्रल वैल्यू अराउंड विच वी वर मेजरिंग द डिस्पर्जन. नाउ द क्वेश्चन इज हाउ विल वी मेजर द डिस्पर्जन ऑफ द वैल्यूज अराउंड द अरिथमेटिक मीन. आपको मालूम तो है कि सबसे ज्यादा फ्रीक्वेंटली यूज्ड एवरेज तो बहरहाल अरिथमेटिक मीन ही है. तो जाहिर है स्टूडेंट्स कि हमारी जो सबसे पहली अप्रोच होगी इस सिलसिले में दैट विल बी वेरी सिमिलर टू व्हाट वी डिड जस्ट नाउ इन केस ऑफ द रेंज एंड इन केस ऑफ द क्वार्टाइल डिविएशन. हमने डिस्टेंसेस मेजर किए थे around those central values, and exactly that we will do now that we want the arithmetic mean to be considered as the central point, and that is that we measure the distance of each and every data value from the mean. Denoting these distances by small d and considering their absolute values, the formula for the mean deviation becomes mean deviation is equal to sigma modulus of d over n. अब इस फॉर्मूले में दो तीन बातें नोट करने की हैं. पहली चीज तो यही कि आपने नोट किया कि मैंने एब्सोल्यूट वैल्यूज कंसिडर की हैं. इसकी वजह यह है स्टूडेंट्स कि अगर मैं सिर्फ डिविएशंस की बात करूं विदाउट कंसिडरिंग द एब्सोल्यूट वैल्यूज, देन some of the deviations will be positive and some of the deviations will be negative. And if I sum them, my answer will be 0. लेकिन जब हम एब्सोल्यूट वैल्यू ले लेते हैं तो इससे ये होता है कि नेगेटिव डिविएशंस भी पॉजिटिव हो जाती हैं, एंड व्हेन वी सम देम वी ऑब्टेन अ पॉजिटिव आंसर, and dividing that by the number of deviations, we are obtaining the average deviation. और इसीलिए इस मेजर का नाम है मीन डिविएशन. आफ्टर ऑल मीन किसे कहते हैं? एवरेज को. तो लुब्बे लुबाब सारी बात का ये कि हमने डिविएशंस लेनी है ऑफ ऑल द वैल्यूज फ्रॉम द मीन. हर डिविएशन की एब्सोल्यूट वैल्यू लेनी है और उसके बाद इन तमाम एब्सोल्यूट डिविएशंस को एवरेज कर देना है. इस फॉर्मूले की डिटेल डिस्कशन हम इंशाल्लाह नेक्स्ट लेक्चर में करेंगे. एंड आफ्टर हैविंग डिस्कस्ड इट in the case of raw data, we will proceed to the case of grouped data, that is, when we have a frequency distribution. After that, we will proceed to the most important measure of dispersion, and that is the standard deviation. In the meantime, I would like you to practice the concept of the range, the coefficient of dispersion, the quartile deviation, and the coefficient of quartile deviation. My best wishes to you, and until next time, Allah Hafiz.